Unit 6 is all about systems of equations and inequalities. Lesson 6.1 is going to be solving systems of equations graphically. So that means by graphing two of them. And what you're trying to look for is where the lines intersect. And so number one, yes, there will be questions like this where they've graphed these two equations for you. And we'll talk about how to do that on the next one. But you're just trying to figure out which point do they have in common. That would be right here. Okay, so this line here has points here and here. You can see where they go through the grid lines, or I call them sometimes the crosshairs, and this one has here. The only time they'll ever have a point in common is at 0, 2. Make sure you're going x before y. All right, number 2. Hopefully remember from Algebra 1 how to graph these. These are in the form y equals mx plus b. The number in front of x is always your slope, which is going to be a rise over a run, meaning a vertical movement before a horizontal movement. And then this b, or this constant, is going to be your y-intercept. So we always start with the y-intercept first. That would be at positive 4. I'm going to put a point. And then my slope, when I don't have a number, is really a 1. So negative 1, to make that a fraction, I'd put it over 1. This is my vertical shift. This is my horizontal. Since this is negative, I want to go down 1. Since this is positive, I want to go right 1. So I'm going down 1, right 1, down 1, right 1. And then I'm going to use my ruler to connect them. Okay, line number 2, switch colors. This time our y-intercept is negative 4, and my slope is 3/5. So I want to go up since it's positive, and I want to go right since it's positive. So I'm going to go up 1, 2, 3, right 1, 2, 3, 4, 5. That happens to be the point where they intersect. Up 1, 2, 3, right 1, 2, 3, 4, 5. And I'm going to use my ruler. So this word pair would be 5, comma, negative 1. Right, number 3. Only thing that's different is the second one is in what's called standard form. Standard form is good for getting intercepts, but we don't want to graph it like that. We want to get it into y equals mx plus b, which is that slope-intercept form again. And so in this one, I'm going to solve for y. So I'm going to subtract this 2x over, because we know that anytime we move a term, it becomes its opposite. I've got negative y equals, I'm going to put negative 2x first, because that's my slope. And then the 6 is positive. I have to divide by negative 1 everywhere. So that'd be y equals, that'd be 2x, 6 divided by negative 1 is negative 6. So that's really what I'm graphing instead of this. Okay, so I'll go ahead and graph that one. I start down at negative 6. My slope is 2 over 1, so I'm going up 2, right 1. Okay, and that's my line. So all of those points I just made, those are called solutions of that equation. They work if I plugged them in. And then this one, I would start up at positive 1, and I'm going, this negative, I just always make it with the top number. So I'm going down 1, but then the 3 is still positive, so I'm going to go right 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. And I was able to easily find where they meet. So negative slopes should from left to right go downhill. Positive slopes go uphill. And they intersect at 3, 0. Okay, and then the last one I want you to just be aware of is sometimes you have where a quadratic or a parabola meets a linear function. And so I'm seeing actually 2 places where they intersect, and that would be at negative 1, 0 and at 2, negative 3. So that's all you're doing on those, because we have not learned how to do those any other way yet. And that's it.